This is the second video in my series on three-phase power transformers. In this video, I'll be looking at the theory behind this topic, which you will find, I'm sure, much less complicated than you expect. You can find out more on this subject in my course entitled Electrical Three-Phase Power Transformer Fundamentals. You can access this and my other courses on my Stan store at this web address. Three-phase transformers can be thought of as three single-phase transformers, each consisting of a primary winding linked magnetically to a secondary winding. They become a three-phase unit by virtue of their excitation voltage and how they are connected to one another. They may also share the same core, but they may be considered individually. Here they are energized by three voltage phasors that are out of phase by 120 degrees, but are joined at one point, or neutral, and the phasors are considered rotating in a counterclockwise direction. Transformer and distribution stations, with very few exceptions, handle three-phase power, and the transformers are either three-phase units or three single-phase units in a bank. The exception to this is where two transformers are operated in open delta to supply three-phase power. This is not a common situation and is usually used in emergency situations. However, it does exist. The connections of a three-phase circuit may be divided into two basic classes, a star connection or a delta connection. The star connection has a neutral point at the junction of the three individual phases, and single-phase loads may be fed from any one of the phases to neutral. Such a connection is used at some transformer station to supply three-phase power to motors and a single-phase power to, say, the lighting system. Delta circuits are mostly used for straight transformation of three-phase power of medium voltage range, where single-phase loads do not have to be provided for. When three single-phase transformers of equal capacity are connected star to star or delta to delta, the capacity of the bank is equal to 3 times the capacity of each of the individual transformers. Note that when the windings of a transformer are referred to as being primary or secondary windings, the winding, regardless of the voltage level, the one connected to the source of the power, is always considered the primary winding. Three-phase electric power is a common method used for the generation, transmission, and distribution of alternating current electric power. This polyphase system is the most common method used by electrical grids worldwide for the transfer of power. The three-phase system was invented and developed in North America by Nikola Tesla in the late 1800s. And I encourage you to go into YouTube and find some of the history of this fellow. He's very interesting. A lot of what he developed is still in use today, and he's a highly underrated inventor. And I think you'd find his life fairly interesting, so I encourage you to go there and have a look at it. As a result of this development, transformation of power between voltage level has given rise to various transformer connections or configurations, the most common of which we are about to look at in the next series of slides. Star-star, sometimes called YY connected transformers, can deliver two voltage levels, phase to phase or phase to neutral, on both the primary and secondary. Also, the terminal bushings can be gradient insulated and hence less expensive to manufacture. With this type of connection, one terminal of the primary terminals is connected to the system, lines, buses, etc. The other terminals are connected together to form a primary neutral. Similarly, on the secondary side, one of the terminals on the low voltage system is connected to the lines and buses. The other terminals are connected together to form a secondary neutral. These neutrals, primary and secondary, are not necessarily connected together, and sometimes they're grounded or not grounded, and sometimes one is and the other isn't, and sometimes they both are. But if they both are, then of course they are considered connected together. The high voltage H1 terminals are connected to the individual phase conductors, and the high voltage H2 terminals are connected together to form a neutral. The low voltage X1 terminals are connected to the individual conductors, and the low voltage X2 terminals are connected together to form the neutral. The transformer having its H1 terminal connected to the red phase is referred to as the red phase transformer. Likewise, the transformer with the H1 terminal connected to the white phase is considered the white phase transformer, and the transformer with its H1 terminal connected to the blue phase is referred to as the blue phase transformer. The vectors or phasors look like this. The red phase, both primary and secondary, disregarding the magnitudes, are in phase. The white phase on both primary and secondary are also in phase, and the blue phase, both primary and secondary, are in phase. The H2 and X2 terminals form a neutral for both the primary and secondary, respectively. They are not necessarily connected together. The phasors are 120 degrees apart and rotating counterclockwise. Transformers for star connection and solidly grounded neutrals may be made with only one terminal brought out in a bushing and the winding insulation graded so that less insulation is required to use towards the grounding. This results in considerable savings in costs when constructing a transformer. This video is part of my Electrical Technical Information series. In this series, I'll be covering essential topics to help you understand electrical systems. Be sure and stay tuned, as I will also from time to time be reviewing electrical products that, in my opinion, are worthy of paying attention to. One of those products is the EcoFlow Delta Pro Ultra. The EcoFlow Delta Pro Ultra is one of the most versatile whole home backup solutions that has just been introduced to the market. This backup power system is designed for both extended outages and daily use. With an unrivaled capacity of 6 kilowatt hours, 7,200 watts output, and 5.6 kilowatts solar input, a single unit can run your entire home. With EcoFlow Smart Home Panel, you get an uninterrupted power backup experience with automatic switchover, energy consumption monitoring, and lower electricity bills. This unit is not driven by gas or diesel generation, but uses the battery storage unit that is charged when the utility is available. This means that the unit can be placed indoors, and it is virtually silent when operating. It has a stackable design that can be expanded to increase output in only minutes. Compatible with various energy sources, from solar to gas, to meet your ever-changing power needs. To obtain a discount code for 5% off on all EcoFlow products and more information on this subject, and pick up your free digital copy of The Ultimate Guide to Residential Standby Generators. Simply fill out the information requested when you go to this website, https://bit.ly/3 Before we end this video, I want to repeat the connection to my free copy of the Ultimate Guide to Residential Standby Generators, and the 5% discount code for all EcoFlow products. Also, here is the connection to obtain a free copy of my 50-page electrical power crib sheets. And finally, here is the link to all of my electrical courses, which are located in my stand store.